Welcome. This is Algebra 2 Calculator Multiple Choice Questions with Ms. Kempton. This is the ultimate guide on how to check your answers using your calculator. I am going to give you all the tricks of the trade. Let's get to it. For question 1, which expression is equivalent? The second we see the equivalent, we know that we can use our calculator to check our answers. The first thing we have to do, though, is give our calculator a number for x. I'd stay away from like 0, 1, 2. I like to just give it a random decimal just to be safe. So we're going to go ahead and stow a number in for x. So 2.15, I'm just using that as an example. We're going to go ahead and plug our original expression in, 2x to the third plus 2x minus 7 over 2x plus 4. Okay, there it spits out a number, and now we're going to plug in our answer choices to see which one gives you the equivalent answer. So the first option we have, we're going to always plug it in exactly the way that we see it on our paper, and you'll notice that option 1 will give you exactly what we originally put in. Now, rest assured that I did plug in all the options for timing purposes for this video. I will tell you that answer 1 is the only one that checks out. Okay, question 2. The expression can be rewritten as. So rewritten is kind of like saying it's the same. It's almost like saying that it's equivalent. So again, I can go ahead and use my calculator trick for this. So I'm going to go ahead and plug in exactly what I see on the paper. And I'm going to go ahead and substitute the options. So option 1, I have 10 over x squared plus 3. So what you notice is that that is not the same. So I'm going to go ahead on to option 2. I'm going to plug this in exactly the way that I see it. And boom, there it is. Okay, I get that 2.18, same exact thing over here. So this is equivalent, and again, rest assured that I did check every option just to make sure that I did not make any mistakes. All right, question 3. Which statement is true for all real numbers? True is just saying that this is a correct identity, meaning that the left side has to be equal to the right side. So again, we're just going to go ahead and substitute in these options. Now, because I have a y value, I'm actually going to assign a random number to y. So I'm going to go ahead and stow that number in for y. In our calculator, I can use alpha, and then the y button, I believe, is maybe under the 1 or the 2, I forget, but it's in your calculator. So right now, my calculator thinks that y is 3.15. I'm going to go ahead and plug the left side of the equation in exactly the way that I see it. Okay, and I'm going to plug in the right side of the equation exactly the way that I see it. X squared plus y squared. And these do not give us the same on the left and the right, so I know that option 1 is not correct, so that's out. That's out. And now let's try the second identity. Let's plug in the left side, which is x plus y to the third power, and then the right side, alpha y plus y to the third power, and they are not equivalent, which means that this is not an identity either. So our answer is neither 1 nor 2. All right, moving on. The key word for question 4 is zeros. So what are your zeros? Your zeros are your x-intercepts. So I can factor this if I want to, but hey, why not use our calculator? So I'm going to go ahead and plug this into our y equals to see where they cross the x-axis. I'm going to plug it in exactly the way that I see it. And I can look at my graph if I want to. Okay, so right away I notice that it looks like it's crossing at -3, 0, 3, and 4. If I want to, I could also take a look at my table, and I'm looking for where the y is 0. So I see it at -3, I see it at 0, I see it at 3, and I see it at 4. So there are two ways to look. You can actually look at the graph, or you can look at the table. And when I look them up, I always want to see I'm actually going to erase this little piece right here. I don't need that. And I'm looking to see where my y's are 0. So I had -3, I had 0, I had 3, oops, and I had 4. So the answer is -3, +3, 4, and 0. Okay, moving on. What is the solution set to the equation? So this is kind of interesting because whenever they're giving us a solution set or asking us what is the solution set, they're actually saying, hey, what is x? And what you'll notice is that if it's a multiple choice question, they're giving us options for what x could be. Okay, so there's a couple different ways you could do this. One thing that I want you to notice right away is that I'm dealing with fractions, and when you have fractions, you're not allowed to have 0 in the denominator. So if x is alone, I know that it definitely can't be 0. Unfortunately for this question, there's no options that say that. Now if x plus 3 cannot be 0, I know that x is also not allowed to be -3. So are there any options here that says that x can't be -3? No. All right, so that means that I'm going to have to check this in my calculator. Now, there are a couple different ways you could do this. You can store your x's and y's in. I'm going to show you another way also. You can actually plug your left side in and plug your right side in, and then look at the table to see where your y's are the same. That's one way to do it. So let's check that out right here. I'm going to go to my y equals. I'm going to plug this in exactly the way that I see it on the left side, which is 2 over x minus 3x over x plus 3. And on the right side, I just have x over x plus 3. All right, so if I go to my table, I'm looking for where my y's are the same. So do you notice that I have a -0.5 here and a -0.5 here? Because those are the same, I know that this actually works out, and one of my solutions has to be -3. And if I scroll here, I don't have any other y values that are the same. So by looking at my multiple choice options, I do see one of them is -1. So I'm going to assume that this is the right answer. Now, unfortunately though, I can't really look at my table unless I change it to check. So let's go the good old-fashioned way, and let's actually store 3 over 2 in and check it. I actually kind of prefer this way, to be honest with you, rather than going to my y equals, but I did want to just show you that option. So I'm going to go ahead and store 3 over 2 in x just to see, does the left side match the right side? So going back, the left side was 2 over x minus 3x over x plus 3. Okay, and on the right side, I'm going to double check that with x over x plus 3, and they do equal each other. So -1 and 3 over 2 both check out, so that is my answer. All right, here we go. Next one is also asking for a solution set to the following systems of equations. So they're actually giving us solutions. So can I use them to plug them in? Absolutely. Now what I'll notice for this one is I actually have equations. So I'm going to go ahead and just plug both of them in and look at my table. So 3x plus 6 is going to go in for one of them. And my other one is x plus 4 squared minus 10. All right, if I look at my table, I'm doing just what I did before. I'm looking to see where are the y values the same. So see the -9 and the -9? That means that one of my solutions has to be -5, -9. And in this scenario, we're not just looking for the x, we're actually looking for the x and the y because it's a system. So I do see -5, -9 there, and I do see -5, -9 there. But do I also see 0, 6? Well, let's check it out. There's my 0, there's my 6 and my 6. So I do have two solutions. So my answer is choice 3. Done. All right, moving on. The next question is a system, again, with 3 variables. So in this case, we are going to use our matrix. So the buttons to do this are going to be second matrix. And once we do second matrix, we're going to scroll over to math and we're looking for RREF. So let's go ahead and do that now. Okay, so second matrix. If you scroll over to the right, you'll see math, and you're scrolling all the way down till you see RREF. Now, once you have RREF, you're going to go ahead and input a table. So the TI-84 is going to be alpha zoom. And you want to highlight the 3 and the 4 and press OK. So for this calculator, it's a little bit different, but I could do my 3 by 4, press OK, and this is exactly what you should see. Now, from here on out, you're going to substitute in the coefficients, which are the numbers in front of your x and y. So that's a 1, that's a 2, that's a -1, that's a 1, and so on and so forth. So I have 1, 2, -1, 1. The next row, I have -1, -3, 2, 0. And then the last row, I have 2, -4, 1, and 10. And when I press enter, the numbers on the right side are going to be your solution. So 3, -1, and 0. So x equals 3, y equals -1, z equals 0, and I have that down as choice 2. Okay, moving on. Question 8. This is a very popular question. We're looking for a solution set, which again means, hey, they're giving me answers, I just need to check them. Now you can do this the long way, but there's a little trick in your calculator. You can either store in your options, you could store -8, store in +8, check the left side, check the right side, or you can actually plug in both sides into y equals and check the table. So I'll show you how easy that is. And I know that it says b, but let's just pretend that that is y, just to make it easier for us. Okay, the left side was just b, which is going to be x. The right side is going to be the square root of 2x squared minus 64. Now we're going to go to the table and we're going to look to see where the left, where our, did I plug something in wrong? No, I didn't. Okay. Okay. So what you'll notice here is that I have an 8 and my y's are the same here and here. Just double checking. I also have 0. What you'll notice though is that your options don't have 0, so we don't have to worry about that. But down here, I have an 8, an 8, and an 8, so I know that my answer has to be positive 8. And there it is, done. All right, moving right along. What is the solution? Again, when they ask us what's the solution and it's multiple choice, they're actually giving us options. So what I'm going to do for each of these is I'm actually going to store them into my calculator. So for this one, I'm going to store this in for x. I'm going to store this in for x. I'm going to store this in for x, and I'm going to store this into x. And then I'm going to go ahead and plug that in to see which one of these options gives me 0. So let's start with option 1. I have negative fraction 3/4 plus another fraction 1/4 I, which is second, and then the decimal down, radical 7. Okay, so I'm going to go ahead and stow this in for x. There it is. And now I'm going to go ahead and plug the left side of that equation in to see if it equals the right side, which is 0. 2x squared plus 3x plus 2. Does that equal to 0? It sure does. So that is my solution. Rest assured that I did try all the options, but I'm not going to do that right now for time purposes. Okay, question 10. Equivalent. We learned before that equivalent means equal to, so we're going to go ahead and plug in our original expression, which is 6xi to the third power times negative 4xi plus 5. Okay, ignore this crazy decimal. This is just for checking purposes. And now we're going to go ahead and plug all the options in. So 2x minus 5i. Nope, that's not the same. Negative 24x squared minus 30xi. Hey, look at that. It's the same. Therefore, it's equivalent. Rest assured that I tried all the options, and that's the only one that I got. All right, for question 11, this one's a little bit different than the other ones, but what I have here is what's called an identity, just meaning that whatever you plug in for sine squared and cosine squared, it's always going to be equal to 1. Now, what's cool here is that they actually gave you what sine is, so I can actually plug that in there, and then they're asking you what cosine is. So is it possible to use our options and plug them in? Absolutely. So because they gave us the sine, I know automatically that I have negative radical 2 over 5 squared plus cosine, and just for calculator purposes, I'm just going to call this x is equal to 1. So what I'm going to do here is I'm going to store each of these in for x to see which one works out and gives me 1. All right, so the first one is 5 plus radical 2. 5 plus radical 2 over 5. I'm going to store this in for x. All right, and let's try it out. So my sine squared, which they gave me, was negative radical 2 over 5 squared plus x squared. So we're checking that first option. The left side has to equal the right side, which is 1. Nope, doesn't work. So let's store in the next option. The next option is radical 23 over 5. Let's store that in for x now. All right, let's go back here. Okay, where I'm just pasting it. If this is equivalent, then it will equal 1, which it is. So that must be the correct answer. Rest assured that I did try the other ones, and this is the only option that works. All right, moving right along. We have again x and y, which expressions are equivalent. So there's a lot of crazy stuff going on here. It's a little bit different, but we can go ahead and use our calculators to test what's equivalent. So I already have a number in for x and I already have a number in for y. So I'm just going to go ahead and plot them. Not plot them, write them. All right, so x to the third over y. I'm going to do my alpha y again. Okay, so right now y is 0, so let's go ahead and give this a number. Store alpha y, boop. Okay, let's do that again. Okay, x to the third over y. All right, there we have it. So our first option, I'm going to input it exactly the way that I see it. Y over x to the third, parentheses, to the negative first power. All right, let's see if it gives us something equivalent. It does. So I know that this first option is equivalent. Okay, so I can cross off option 3 because it's not including 1. Let's continue with option 2. Option 2 has a cubed root, so I'm going to go down to here, the cubed root, x to the 9th power, and I'm going to multiply that by y, exactly the way that I see it, to the negative first. And does that get us equivalent? Yep, that 0.28. All right, that also works. So I know that so far 1 and 2 are good. Okay, so it can't be option 2. So it has to be either option 1 or option 4. So let's go ahead. I got a lot going on with that last one, but I'm going to substitute it in exactly the way that I see it. So x to the 6. Now I do have a root here, and some of my students tell me that if you try the option with the x, it automatically inputs what you had as the root. And I've noticed that that kind of does the same thing. So what I like to do is when I press math, I like to hit the cubed root, and then I like to go back and just go over it. So now it's kind of separate. There is my y to the 8th power, and now I have x to the 3rd and y to the 3rd. All right, that's exactly the way that I see it, and it's the same. So therefore, options 1, 2, and 3 all worked out. So choice 4 is the correct answer. All right, moving on to 13. Which statement is true about this graph? So this question's just here to kind of just remind you that if you have an equation, you don't have to know what it looks like in your head. Graph it, okay? So 1 over 8 to the x power. You don't have to know every little thing that they give you. I'm going to plug it in exactly the way that it shows, 1/8 to the x power. When I graph it, I notice right away that it's going down, okay? Does it pass through 1, 0? Well, let's see. If I look at my table, no, it doesn't pass through 1, 0. It passes through 0, 1. So the graph is decreasing, so that is the correct answer. And the asymptote, by the way, is y equals 0, not x equals 0. Question 14 is very, very similar. It says, which expression defines this? Well, guess what? I have 4 options here. I don't have to know what they look like in my head. I have points right here. So plug the equations in to see if they match the points. So the first equation is 2x. So if I go to my y equals and I plug in 2x, and I go to my table, okay, I'm looking for 2, 10. Nope, that's not it. That's out. Okay, let's do the next one. 5 times 2 to the x. Let's go to the table. I'm looking for 210. Nope, that says 220. That's out. Let's go to the y equals 5 times 2. I have my exponent, that's a fraction, x over 2. Okay, let's go to the table. And hey, look, there's 210, there's 420, and there's 640. So I didn't have to know exactly what each of them looked like. I used my calculator to match them. All right, 2 more questions. What is the solution? Yes, if you want, you could do this using logarithms. But hey, they're telling me that one of these options is a solution. So can I store them into my calculator? Absolutely. Let's store each of these in for x. Okay, so the first one I'm going to store is ln 6 over ln 2. The ln is right underneath the log button. So ln 6 over ln 2, and then minus 3. I'm going to stow this in for x. All right, and now I'm going to go ahead and plug in the equation that I see. X plus 3. And this is supposed to equal 48, does it? Oh my goodness, it does. There you go. Rest assured that I did try every other option, and that was the only one that worked. All right, and the last question, this one's a pretty popular one. Which value to the nearest tenth is not a solution? Okay, now, whenever they set the functions equal to each other, they only want the x values. Now, in our calculator, we're going to have to figure out where these intersect. So to get the intersection button, you're going to go to second trace, and you're going to hit intersect. Okay, so go to your y equals. You're going to plug the first function in, x to the third plus 3x squared minus 3x minus 1. The second one is 3x plus 8. Now, it might be a little bit hard to see on a regular calculator because you can't, do your window like I can. But if you do go to second trace, sorry, I'm trying to look to see. Oh. Graph, calc, where is it on here? Sorry, give me a second here. Second trace. Nope, that's not it. That's not it. Okay. When you go to second trace and you click intersect, you're just going to move your left and right arrows to see your intersections. Once you get there, okay, left and right, you're just going to press enter, 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 and you're looking for just the x value. So you'll notice that the x value for this one is negative 3.9. The x value for this one is negative 1.1, and the x value for this one is 2.05, which is closest to 2.1. So the only one that we did not have is 4.7. Okay? Take a look. Let me know if you have any questions with these, and I'll see you later. Bye.